Morning class. Hello, good morning. Today there was some difficulty in connection, so I am a bit late. Please class, join quickly. Good morning class, please come on all of you. I have worked out the problem. There was some fault in the connection, so please bear with it. Okay. Now class please. So we are doing this linear equations in two variables. Please join quickly. Yes class. So today we will understand the graphical solution of linear equations by activity method. Okay, yesterday we have discussed that the linear equations in two variables, that is the topic we are doing right now. We have found how to, by comparing the coefficients, you can say whether the graphical solution will be a unique one, no solution, or it's going to be infinitely many solutions. That we have discussed yesterday. Please come on all of you, join quickly. I'm sorry for the delay. There was some mistake in the connection. Some problem was there. So I am able to finally chalk it out and I am ready with you. Please join. So yesterday, before some of the more students joined, I talked to you. And yesterday in the live chat, I found two queries were there. One of the student asked about the linear equation. And another question was, that was a very valid question, that if the lines are parallel, why it is said to be a no solution? These are the two questions I found in the live chat box. So I answered to that question. For the linear equation part, I would like to say that you may not have attended my previous class. I have talked about linear equation for so many times. Linear equation means the equations where the power of the variable is 1. The maximum power is 1. Linear polynomial, the maximum power of the variable is 1. And if it is an equation, then it is equated to 0 or some other constant value. Anything, there are two parts, left hand side and right hand side, that is an equation. And in an equation also, if the maximum power of the variable is 1, it is said to be a linear equation. Okay, I think this is clear. Now one question, that if the lines are parallel, then why it is said to be no solution? For that I would like to say, see, if you are having intersecting lines, that is this type of an intersecting line, this line is moving in this manner and another line is coming from this side, okay? They are moving on two different paths, but when they cross each other, there is one point. This point is common to both the equations. This line is for one equation and this line is for another equation. And all these points lying on this line is a solution for this equation, and the points over this line will be the solution for the other equation. But this particular point where the two lines meet, that is a solution for both the equations. So that is said to be the unique solution. And another case, if you find two lines are parallel, then all these points lying on this line are the solution for this equation, and the points on this particular line are the solutions for the equation of this line. Now, for parallel lines, you find there is no point common to these two lines. Is there any point which is common to these two lines? No, they will never meet each other. If we talk about some story, see, there are two persons, they are arguing, in no point they agree to each other, but by chance at certain point they agree to each other, so that gives a solution. There comes the end to the argument. But if these two cases are there, In no point the two person while arguing to each other, they never come to a conclusion. There is no solution. They are always, their views, the two persons, their views are always different. So they will never be able to settle down and there will be no solution to such a problem. So this line is on its own path and this line is also moving on its own path. They have nothing in common, no point in common. So this is said to be no solution. If the lines are parallel, they have no solution, no common point. If the lines intersect, they have one point in common, that is said to be the unique solution. And if these points of one line and another point of the other equation also lies, the two lines merge together, and in this way you get infinite solution. You get infinite solution. All the points of one particular equation will satisfy the other equation as well. So if the two lines merge, that is the case of infinite solution. Well, my dear class, I think you people have joined now. So today's class we are going to do an activity method. This again you can note down in your lab manual. This you can note down in your lab manual. This is activity 2 and what I have done over here, see, these equations are visible to you. I have drawn this graph. I will show them on the screen as well as I have demonstrated you yesterday. See, I have written the objective to verify the conditions of consistency. Verify the conditions for consistency. That will be the activity 2 objective. Verify the conditions for consistency. Now, what do you mean by consistent? In today's class, we are going to learn two keywords, that is consistent, and another word you will come across is inconsistent. Okay? Consistent and inconsistent. This means what? If there is a solution, consistent means there is a solution is possible. For a linear equation in two variable, solution is possible, that is said to be consistent. Solution is possible. And in inconsistent, that is your solution is not possible. Solution is not possible, then that is said to be your inconsistent. Okay? Consistent and inconsistent. Consistent means solution possible. Inconsistent means solution is not possible. Now, consistent, you come across two cases. In case of consistent, you have got two cases. Number one is your unique solution. Unique solution. There is just one solution. And another one is solution is possible, and there you have got infinite solutions. So, consistent means unique solution or infinite solution, and inconsistent means no solution. Okay? So, solution hai, another one is solution nahi hai. There is no solution. So, solution is possible means unique solution and infinite solution. Solution not possible means no solution. This is your no solution. So, remember these are the terms used, consistent and inconsistent. Okay, for a pair of linear equations, there are two possibilities. They may be consistent or they may be inconsistent. If they are consistent, then it could be unique solution or it could be infinite solution. Okay. So, now, our objective is to verify the conditions for consistency. Conditions for consistency. So, in this activity, you need to write the objective and prerequisite knowledge, that is plotting of points on the graph, that you have already studied in your 9th class. You know how to plot a point on the graph. That is one of the previous knowledge required. Then finding solution for the equation and concept of intersecting coincident lines. Okay. Now in this case, our equation, the first equation is 2x minus y minus 4 equal to 0. Okay. In order to find the points, some solutions of this equation, what we will do, Okay, so we can take this y with coefficient minus 1 to the other side. Then this will be 2x minus 4 equal to y. Okay, I take the 1 with coefficient minus 1. This is minus 1. So I take it to the other side. This becomes y, and in the left hand side you have got 2x minus 4. You can write it as y equal to 2x minus 4. Now we will try to find the points, some solutions of this equation. You can put any value of x and you will get the value of corresponding value of y. Say if you put x equal to 0, if x is equal to 0, then your y is equal to minus 4. You put it here. Now, if your x is equal to 1, then your y is equal to x equal to 1 gives y is equal to 2 into 1 minus 4, that is minus 2. Minus 2. In this way, if you take x is equal to 2, then your y will be equal to 0. In this way, you will prepare the table for one of the equations. Say this one. I have prepared this table. And for the other equation, I request you to please prepare the table for the other equation. And then we will see how we plot the graph equal to b1 upon b2. And we have, from our previous knowledge, we know if a1 upon a2 is not equal to b1 upon b2, then we are going to have intersecting lines. Then we are going to have some intersecting lines, that is unique solution. And what is that solution? The two lines meet at one common point, that is your unique solution. In this particular graph, see, I have plotted the graph on the graph sheet. If this is not visible, I will bring a graph sheet on the screen itself and you will be able to locate the points. But in your notebook, you need to present it in this manner. You need to write all this, your objective, pre-required knowledge, and then you will paste the graph. Okay, now we will go for the graph. I hope you can see the graph on your screen. I will write down the equation. See this graph. This is you can see this equation 2x minus y minus 4 equal to 0. Yes. So now you can see the graph. The equation is 2x minus y minus 4 and the points we have calculated, that is x equal to 0, y equal to minus 4 and x equal to 1, y equal to minus 2, x equal to 2 and y equal to 0. Okay. Similarly, for the other equations, just now we have calculated these points. So this point, you see this point, these are the points, the tables is in front of you. So x equal to 0, this point, you see this point is your 0 minus 1. 0 minus 1, that is this particular point from the second equation. Then this one is your 1 comma 0 and this is your 2 comma 1 from equation number 2. This is with blue color. And in the other equation, the first one, you have got this point. This is 2 comma 1, 2 comma 0, this point, and then you have got this one. This is your 0 comma minus 4. Okay. I will try to zoom it out. Now you can see it carefully. See this point? This is 0 comma minus 4. You have calculated this point for the first equation. Then this point is 2 comma 0, and the two lines, they meet at this point. This is your 3, x-axis is 3, and y-axis, this point, you see this is your 5, this is 5, this is 0. So 1, 2, 3, 4 and 5. This point, this is your 2. This is on the axis 2. So this point is 3 comma 2. So the solution for this linear equation, pair of linear equation is 3 comma 2. Okay. So the first one you have. Now, so we have seen that for intersecting line, a1 upon a2 is not equal to b1 upon b2. Now, for the second part, your equation is, so I remove the first one now. For the second one, this is your 2x plus 4y minus 10 equal to 0, and 3x plus 6y minus 12 equal to 0, and the table you are going to prepare it. This is your x and y, and for the first one, what you will do now, this is your 2x, the coefficient of x is 2. So we can write this equation as 2x equal to 10 minus 4y, and because this is 2, so x is equal to 10 minus 4y upon 2. Now for values of y, say 1, 0, 1 and 3. If y equal to 0, your x is equal to 5. Y equal to 0, this part goes to 0, 10 upon 2 is 5. If y is equal to 1, then this is 10 minus 4 is your 6, 6 upon 2 is 3. So this is 3. If y equal to 3, then 4 into 3 is 12. This is your 10 minus 4 into 3 if you take for the last one. This is your 10 minus 12 upon 2, that is minus of 2 upon 2, that is minus 1. So if this is 3, this is minus 1. So I hope these calculations are clear to you. You can calculate the solutions of the linear equations and prepare this table. And similarly for the other one, you can see the table, note it down, x and y. This is your 4, 2 and 0, 0, 1 and this one is your 2. This you can calculate and verify this table. Now, what we will check, we will see whether it is going to give us a intersecting line, parallel line or coincident line. See a1 upon a2. What is a1 upon a2? This is 2 upon 3. a1 is the coefficient of x of the first equation, and a2 is the coefficient of x in the second equation. So this is 2 upon 3. And what about your b1 upon b2? b1 upon b2 is equal to 4 upon 6. So this is 2 upon 3. Okay. And then c1 upon c2. c1 upon c2 is your minus of 10 upon minus of 12. So this is minus gets cancelled. So this is 5 upon 6. Okay. Minus gets cancelled. So this is your 5 upon 6. So in this way you see that a1 upon a2 is equal to b1 upon b2, but this is not equal to c1 upon c2. So the condition is a1 upon a2 equal to b1 upon b2, but not equal to c1 upon c2. And yesterday we have seen that this condition is going to give you parallel lines, and parallel line means no solutions. So this is parallel lines, that is no solution. You can see in the graph plotted here, these are the two lines. This is one. You please mention the equation. This is the red line and the other line for the other equation. The first equation with blue line and the second equation is drawn with a red line. Now let us see it on the screen. This is parallel line, and for parallel line, that is no solution, condition is A1 upon A2 equal to B1 upon B2, not equal to C1 upon C2. So if you want to see it on the screen, see, this is the equation, the first equation, 2x plus 4y minus 10 equal to 0, and this is the other equation. And the two lines are shown on the graph. You can verify these points. These are the parallel lines. Okay. Okay, so this is parallel line, and you can see x equal to this point. This is your 4 comma 0. This is from the second equation, 4 comma 0. Then this one is your 2 comma 1, and this point is your x is 0, y is 2. And in the other one, other equation, you see this point, this is minus 1, 3, and this one is your 3 comma 1, and the other one, this is your minus 1, this point is your 5 comma 0. You can see it if we zoom it out. Okay, these points are clear. This is your 0 comma 2, this is C2 comma 1, and this one is your 4 comma 0. The coordinates, these three are collinear points. Lines in a straight line are said to be collinear. So this is one equation, another, the graph of first equation, one equation, and the other one, this one is your x is 5, y is 0. This point, this is x is 3, y is 1, and this point, this is x is minus 1 and y equal to 3. So in this way you get two lines which are parallel to each other. They never meet, so they never come to a solution, and for parallel line we have no solution. And condition is A1 upon A2 equal to B1 upon B2, but not equal to C1 upon C2, right? So once again we move. So we have done and in the third case, finally in the third one, the equation is your 3x plus y minus 2 equal to 0, and the other one is 6x plus 2y minus 4 equal to 0. Now the points that you get, please check it. You prepare your table like this, x and y. If x is 0, y equal to 2. For calculating it, again y with coefficient 1, you can write it as y is equal to 2 minus 3x. Now you put the values of x. If x is equal to 0, y equal to 2. If x equal to 1, then your y is equal to, if x is 1, then this is your minus 1. If x is equal to 2, this is your 6. So 2 minus 6, that is your minus 4. So this is the table for the first equation. Similarly, for the second one, In order to calculate this value, you can write it as 2y equal to 4 minus 6x. Therefore, y is equal to 4 minus 6x upon 2. Now you prepare the table. This is x and y. If you put x equal to 0, then y is 4 upon 2, that is 2. If x is equal to 1, 4 minus 6 is minus 2. Minus 2 upon 2 is your minus 1. So x is 1, y is minus 1. If x is equal to 2, then 4 minus 12. 6 into 2 is 12. That is 8 minus 8 upon 2. So y will be minus 4. So this is the table, and if we plot these points, you will see these points, they all lie in a same straight line. That is the equation of both these equations, they coincide. Therefore, they are going to give you infinite solutions. Now, if we consider the coefficients, a1 upon a2 is equal to 3 upon 6, and b1 upon b2 is equal to 1 upon 2, and c1 upon c2 is equal to minus 2 upon minus 4. So this is 3, 1, 2, that is 1 upon 2. This is also 1 upon 2, this is 1 by 2, and minus minus gets cancelled. 2 by 4, that also gives you 1 by 2. So a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, all are equal. So this is the line coincide. The two lines, they merge together and they give you a single straight line. See, this is the condition for infinite solution. This is the condition for infinite solution. So you see a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. So all the ratios of the coefficients, they are same, and this is the condition for infinite solution. This is the condition for infinite solutions. Okay. So all these are same. So the coefficients ratio is same. That means they have got all the solutions are same. That is your infinite solution. Now if you plot the graph, so the conditions for unique solution, a1 upon a2 not equal to b1 upon b2. For no solution, a1 upon a2 equal to b1 upon b2 but not equal to c1 upon c2. And for infinite solution, a1 upon a2 equal to b1 upon b2, and that is equal to c1 upon c2. Now let us plot it on the graph. See the first equation. So this is the graph sheet. Now if you write down the equation, this is say 3x, I am writing the equation 3x plus y minus 2 equal to 0. Okay. Now see these points. X you have taken as say 0 and your corresponding value of y is 2, and for another value you have taken x equal to 1, and y equal to minus 1. Sorry, y equal to minus 1. And similarly the third value we have taken, that is x equal to 2 and y equal to minus 4. Okay, so these are the 2 points, right? 0, x is 0, y is 2. Then this one is your x equal to 1, x equal to 1. This point is your x equal to 1. 0 and 2 in between the midpoint, this is your 1. And this one 0 and minus 2 in between, this is minus 1. So this point is 1 minus 1. And then finally this one is x is 2 and y is minus 4. X is 2, y is minus 4, right? So these are the 3 points of the first equation. Now the other equation is your other equation that you have taken, that is your 6x plus 2y plus 2y and minus 4 equal to 0. See, so the two lines, they merge together, and if you have taken the points, then see, the points are like, we have taken x equal to 0 and y is your 2. Then you have chosen the point x equal to 1 and y equal to minus 1. Then finally one more point, we have taken 3 points, so x equal to 2, y equal to minus 4. So these are the 3 points, 2, minus 1, these are the same points. You can see from both the equations you have obtained same points, and the two equations, they merge together, that is, it's going to give you infinite solutions. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Okay, so now we are familiar with all these conditions, and while writing your activity in the notebook, finally after plotting these three equations, you write down the conclusion. The conclusion that you write will be in this manner. You make 3 columns, like give the heading conclusion, number 1 column, that is your graph. Then the other column will be the ratio of coefficients, and then final column will be your interpretation, will be the interpretation. So write down the equations. For the first case, this is your 2x minus y minus 4 equal to 0, x minus y minus 1 equal to 0. So the ratio a1 upon a2 is equal to 2 upon 1, and b1 upon b2 equal to minus 1 upon minus 1, that is 1. Therefore, a1 upon a2 is not equal to b1 upon b2, that is unique solution. This is your unique solution. Then in the other box you write it like this. The second one, again you write down the equations, then you write down a1 upon a2, and then you write down b1 upon b2, and then finally the c1 upon c2. And then if they are equal, if a1 upon a2 equal to b1 upon b2 equal to c1 upon c2, your coefficients, then you say this is a parallel line with no solutions. Parallel lines with no solution. Okay. So by comparing the coefficients, initially we can predict what type of graph we are going to get. Okay, now we will move for our textbook, and we will try to solve the question from our textbook. And this activity, I hope you can do it for take three different types of cases, one for unique solution, and another for no solution, and one for coincident lines, that is infinite solution. Draw the graphs, paste it in your piece of paper, and prepare your lab note. Lab manual book. So now exercise 3.2. 3.2. Okay. Now exercise 3.2. Do this question. On comparing question number 2, on comparing A1 upon A2, B1 upon B2 and C1 upon C2, find whether the lines representing the following pair of linear equations intersect at a point, are parallel or coincident. So the first one, 5x minus 4y plus 8 is equal to 0, and the second equation is 7x plus 6y minus 9 equal to 0. So A1 upon A2 is 5 upon 7. Okay, and B1 upon B2 is equal to minus 4 upon 6, that is minus 2 upon 3. So A1 upon A2, A1 upon A2 is not equal to B1 upon B2. So what do you conclude? This is going to give you a unique solution. Unique solution is expected. That is, if you draw a graph, you are going to get intersecting lines. This is question number 2. You can plot the graph. Now your exercise will be in the homework. You draw the graph and you find out the solution. What is the unique solution? Now question number 2, second part. Second part is your 9x plus 3y plus 12 equal to 0, and another one is your 18x plus 6y plus 24 equal to 0. So now here A1 upon A2 is equal to A1 upon A2 is equal to So you have calculated A1 upon A2 is equal to 9 upon 18, A1 upon A2 is equal to 9 upon 18, and B1 upon B2 equal to 3 upon 6, and C1 upon C2 is equal to 12 upon 24. So this is equal to your A1 upon A2 is equal to 1 by 2, B1 upon B2 is also equal to 1 by 2, C1 upon C2 is also equal to 1 by 2. So A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. From this equation, so what do you conclude? This is going to be your what? All the coefficients are equal, so this is infinite solution. Infinite solution. Okay, and the lines, they coincide. So coincide lines. Now the question sometimes come like state whether they are consistent or not. Okay, if this term is asks you that whether it is consistent or not, so unique solution means yes, the equations are consistent. You are going to get some solution, that is the unique solution. And if again for infinite solution also this is consistent, that is solution is possible. How many solution is possible? Infinite solution is possible. So both the cases this is your consistent. Now exercise 3.2, The third question. The third one is your 6x plus 3y minus 3y plus 10. 6x minus 3y plus 10 equal to 0, and the other one is 2x minus y plus 9 equal to 0. So now we do a1 upon a2. a1 upon a2 is equal to 6 upon 2, that is 3 upon 1, and then b1 upon b2 is equal to minus 3 upon minus 1, that minus minus gets cancelled, equal to 3 upon 1, and c1 upon c2 is equal to 10 upon 9. So from this we get a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. So if this is the case, this is the condition for parallel lines or no solution. Another term used for it is inconsistent. So this is no solution, that is your inconsistent. No solution means inconsistent. Inconsistent. And another one is, if we talk about the graph, this is your parallel line. This graph is going to give you parallel line. So these terms you remember: no solution, inconsistent, and graph is of parallel line. So this is exercise 3.2, question number 2. Now the third question is also similar question, question number 3. Question number 3, that also of the same type. On comparing a1, a2, b1, b2 and c1, c2, find out whether the following pair of linear equations are consistent or inconsistent. Now they are not asking you whether that is about the graph, that is parallel line, coincident or intersecting. Just you need to say consistent or inconsistent. So for consistent, remember this thing. For consistent, and another one is your inconsistent. Once again I am repeating it because these are the key words of today's class: consistent and inconsistent. Consistent, there are two conditions, that is your a1 upon a2 is not equal to b1 upon b2. Another consistent condition is your for infinite solutions, that is a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. If these two are the conditions, then this is your consistent. And for inconsistent, a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. This is the condition. This one condition for inconsistent, consistent, these two are the conditions. So using this, by comparing the ratio of the coefficients, you can do question number 3. So for your homework, I give you few questions for homework. That will be from your exercise 3.2. In our class today there was some difficulty initially in the connection, so I feel sorry for that, but after that I think it went on well, and everything was visible on the board, and I think I am audible enough. If you have any difficulty in today's class, please let me know through the live chat, because yesterday whatever the problems I have come across, the students, they have posted their queries, I have answered you, and similarly this process should go on. Let it be interaction platform be on, and you let me know about what all we have learned, though it's nothing. We have simply come across the two keywords consistent and inconsistent that we have discussed in detail. I have shown you how to plot the graphs on the screen, as well as whenever you are plotting the graph on the graph sheet, how you need to plot it and maintain your lab work. That's what we have discussed today. And tomorrow, dear students, I will like to, if possible, I will prepare a quiz for you. So whatever you have learned so far, I have done two chapters with you. Though this chapter has not been finished yet, that is linear equation in two variables. We yet to do exercise 3.5, 3.6, but let us have a break tomorrow and I will try to prepare a quiz for you. So for that you need to prepare your previous chapter, that is your polynomials, as well as whatever we have done, the concepts of this chapter, chapter number 3. So few homeworks, please note it down. Few questions for your homework. Homework from exercise 3.2. Question number 4. Question number 4. Which of the following pair of linear equations are consistent and inconsistent? If consistent, means if solution is possible, then obtain the solution graphically. So in this way there are 4 parts. 1, 2, 3 and 4. You need to attempt all these 4 parts, and remember, you first calculate the ratio of the coefficients A1, A2, B1, B2, C1, C2, and if it is consistent, then go and find the solution graphically. So for consistent graphical solution, you know the graph will be either an intersecting line or they are going to be the coincident line, the two lines that coincide. Okay, so with this we come to the end of today's class. Thank you very much, and at the same time sorry for the delay and connection problem. We will try to fix it and be in time tomorrow. Goodbye till then. Bye bye. Take care.